Good afternoon, everyone. I'm Manuel Fernandez Monteselo. I was working on the Debian GNU Linux board for RISC-V 64 bits. And I'm going to explain about the status, the history, progress, and so on. First, I'm going to speak about the goals of this project and why a Debian port for RISC-V. Then, what is Debian and what is a Debian port? Some of you may not know. And the original plan, history and making of, current status, and finally how the RISC-V community can help to improve it, and what are the benefits for the community. So the goals of this project is to have Debian ready to install and run on RISC-V-based systems, fully integrated with the Debian infrastructure, so it's not to take a version and make it work and forget about it, so it's to have continuously working from now on. And with time to make it as well supported as the big architectures right now, which are the x86, which is called AMD 64 in Debian for historical reasons, and ARM64 or PPC, PowerPC 64-bit CL. Why Debian port for RISC-V? One is for personal reasons, that I'm interested in both projects. I'm already a Debian developer and contribute in other ways. I like the RISC-V design and goals, and I started following in 2014. I think that they are a good fit philosophically and technically, and I would like to improve and help to grow both projects, so help with that. I worked previously in the OpenRISC or 1K port for Debian and had lots of fun, and that's how I came to know about RISC-V. And at the time when I started, there were no other major Linux distributions inside for RISC-V. So ultimately, if I wanted to run free software and Debian one day in the board, I will have to work on it, right? And the goal changed lately because now there is hardware, so I like to run Debian on my hardware, so there's another incentive to make it work well on the hardware. Technically, I was telling before that I think that there are compatible projects for technical and philosophical reasons. Debian already welcomes and supports many ports. For example, some of the ones appearing in the RISC-V genealogy, for example, there are many of the architectures named there, or they were in the past Debian ports. And they are aiming for openness and freedom. Both are built upon the same tools and based on the same tools, like the GNU toolchain, Linux, and the FOSS ecosystem. For example, if RISC-V was only working on Windows, this will not be possible, obviously. And they are striving for good technical solutions over other considerations like legacy. Debian as a project is mostly a community of individuals, mostly volunteers. Some of them are working for companies or laboratories, but there's no overall control. And these individuals, we care about free and open source software with the goal to create a full, comprehensive operating system, a large collection of software that works well together, and with the stable releases every 2 years, more or less. And software freedom was always one of the core goals of Debian. It appears in the foundational documents and in the subsequent documents created afterwards. And as a Linux distribution, which is what most people know is one of the oldest ones, appearing in '93 for the first time, is the basis of the dev packages, as the name implies. There are more than 27,000 source packages now. A source package is for example, LibreOffice or OpenSSH or Firefox. Some of them produce many binary packages, so there is always this difference in how many packages are supported and so on. And Debian is the basis of many derivatives, like Ubuntu, which is the most popular, more popular than Debian in most places, Raspbian, the version for the Raspberry Pi, and SteamOS for consoles. Valve is working on that, having a port of Debian, and even Tails, that somebody called Edward Snowden was using at some point. And despite being a version of Linux, also supports other kernels like the FreeBSD and GNU Hard, only experimentally, but they are there and people use it for a long time. So Debian port is, in short, is the combination of the ABI of the computer architecture and the OS and glibc. We will see the computer architectures later. And kernel and C library, it's mostly Linux except these two exceptions that I mentioned. And all of the successful ports in the infrastructure use glibc, even FreeBSD kernel. But there are people experimenting with Muscle, for example. And there are three kinds of ports, really. What it could be called a port, which is some of them could be outside Debian. For example, RISC-V is mostly an optimization or a recompilation for Raspberry Pi. And there are people working on MIPS computers in Russia called Baikal. They have their own distribution. Then they can be unofficial or unsupported, which are not in stable releases, but they are still present and hosted in the Debian infrastructure, and then the ones which are part of the stable releases. All of them lately, in the last decade at least, they didn't born as fully supported ports. Even ARM64 or PowerPC 64, they started as these unofficial unsupported ports first, and then they were promoted to officially supported one. So the criteria to become an officially supported port is to be able to build most of the packages. Most means something like 98%, and have enough people responsible for it to fix problems that appear in the stable releases over the years for the lifetime of the release, and to have hardware available and redundant for the systems compiling the packages, and they have to be administered by sysadmins. And in return, the benefit is that they become supported for the lifetime of the stable release, which is 3 to 5 years for all packages. Unofficially or unsupported is when they don't meet some of these criteria. For example, there is no people to support the port, or if they are missing Java or Haskell, or they have problems with some part of the ecosystem, so maybe they cannot become fully supported port, but they are still present in the infrastructure. They can be installed from Debian.org addresses, kept up to date, cryptographically signed, and all that. And crucially, when people upload packages, new versions of the packages, they get also built for all of the architectures. So when people are fixing their own packages, they become available in all of them. The current active ports are the x86 ones, and ARM, some of the MIPS ports, several versions, the Little Endian, Big Endian, and PowerPC and IBM S390. And the ones which are currently not well supported are Alpha, Itanium, Motorola 68K, and all of these were sometimes fully supported ports in the past, but they are becoming old and not very well supported now. And even older ones like Spark 32 bits. And this is, I don't know if you can see all of the details, but the important one is that you can go to this address and see the status of the package. When people see, this is for the Firefox package, for example, there are three important parts, which is the port name, which is the left-hand side. In the center, there's the build status, and in the left-hand side there are details like the logs. So every time that a maintainer uploads a version of the package, immediately or in a few hours, can see the status of the build of their own package, and they might decide to, for example, for this new RISC-V 64 architecture, decide to see what's going on and try to fix it. And this is the original plan, which was to create a few viable basic system, operating system image, and get it to the point to be imported in the infrastructure, to be an unsupported port. For that, it has to have auto builders, documentation, and import a Bootstrap set, and then build as many packages as possible, and then at some point, a few years down the line, to hope to become a fully official port. the target for the software for this port is Linux kernel, glibc, and GCC toolchain, which is what all of the successful ports use. LLVM has a possibility to be available at some point, but not to be the main toolchain. And the userland is the same for all of the Debian ports. For the hardware, the target is 64-bit Little Endian, because they were the systems announced since the very beginning, like low risk, and then what it became as the Sci-Fi Freedom Unleashed. And we decided as the baseline to use the compressed extension, as it's the default flavor recommended by the people involved, and could be reverted if needed or have both flavors. We have architectures with Little Endian and Big Endian, for example, so this is not really a big problem if there are computers in the future that need that. And we didn't consider 32 bits or 128. 128 is a bit too early for that, but maybe in the future, who knows? And 32 bits are problematic because there are no cores, no hardware available that targets Linux, so able to run Linux. And from the Debian side, the 32-bit ports are being problematic already because some of the big packages, they cannot be compiled. The requirement to build or to link them, it's too great for the address space of these ports. So this is where we are now. According to the original plan, we are imported everything in the infrastructure, and we are trying to build as many packages as possible. I started this in 2014, and in the initial years, really, everything was shifting. The documents were not ratified yet. The support for QEMU, it didn't have network. It was targeting different spec, so older specs, not the latest ones. And even then, I was able to create, early on in 2016, a basic system with what you expect from Unix, like make, bash, tar, gzip, specific Debian tools like the package unapt, and even some X Windows packages. And everything was built quite cleanly, and it was working, so it was a good proof of concept. And I presented that at the fourth workshop at MIT. And Fedora started about that time as well, and we hit a very big problem by the later in the year. It's because the ABI changed in a way that all of the work that we had done previously, suddenly the packages that we compiled before could not be used to build support in the latest packages. So basically, both Fedora and Debian, we mostly stopped at that point. And we were waiting basically for the upstreaming of Linux and glibc to finally freeze the ABI, as some of people explained early this morning. And during that time, I was working on making bootstrapping easier, but when we really started again was in late February this year, after glibc was in Debian. We started by cross-compiling the base set of packages that we had before, more or less, to create a system that can run by itself under QEMU. So it's not native in hardware, but it's like a native system in a way. And since there were some bugs in the packages, so cross-compiled, we built natively again. Make, for example, couldn't compile some packages straight away. It had some bugs that prevented it from that. And with this first native build, we created an isolated environment similar to what became later the production auto builders to compile each package separately. So create a basic system, install of the dependencies for this specifically for this package, and get the binaries in the end, and use these binaries to feed and continue compiling the rest of the packages that need those. And by the end of March, so a month later, we imported this second decantation of the Debian ports in the infrastructure. So this is the seed that it's from which the rest of the Debian port uses. And from that date, we are just breaking dependency cycles, some packages depending on other ones, and adding support when needed, or fixing the packages with tests that failed. And this is the status nowadays. Well, this was the status 1 week ago. As Christy and others presented today, we are already at about 80% and crossing the line with the rest of the architectures in Debian ports. So there are about 10,000 of them now, which depend on the architecture, plus another 10 or 50,000 that are architecture independent, like Python or Perl modules, for example. They usually work, as long as the interpreter is available, obviously. And as time goes on, the process slows down a bit because there are several versions of GCC per week, and sometimes GCC takes a few days to compile. So as more packages get built, the progress is going more slow. And what we have available now is all kinds of software, really. We have server-side, Apache, engines, mail servers, voice over IP, 3D applications like OpenSync Graph, media players, even VLC, which is sometimes using Windows and other platforms. Most of the desktops and complex programs like GIMP, Inkscape, and so on for 3D design and from graphics design, and even science. Many science programs that take days to compile or OpenMPI. So it's very timely that we have the V extension now. And what is not available is Firefox and Chromium, for example. Chromium needs x86 or ARM platforms, so it's not available in other platforms at the moment. Firefox needs Rust. Rust needs LLVMs. This is not available until LLVM is available. OpenJDK, it's missing JIT, the hotspot. So it's running what it's called Project Zero at the moment. Haskell and Golang and so on are missing, and then LLVM and GDB, as we explained, and Valgrind. There are some missing parts that we didn't tackle yet. I can skip this one. So they are built, but do they work? And I think that they work pretty fine because they are able to build thousands of packages. Most of them pass tests straight away, or maybe, for example, I had a case of 8 failures of tests in more than 15,000, and there are more failures in other architectures for that. I tested that in the High-Five Unleashed board, and it was fine. Of course, there can be bugs everywhere, and we already found bugs in the QEMU emulation. It was crashing the emulation sometimes, miscompilations, and problems with timeouts of tests and everything. And, well, you will see the demos, which are more impressive, like these pictures right now, but this is what you can do today. It's to SSH. I was doing yesterday from my hotel to the High-Five Unleashed that I have at home. SSH and see the hardware, and you can see the basic dpackage and apt of Debian, so the versions that are currently in the archive. And I'm a user of Emacs, but I wanted to take the picture as a graphical image that I don't really use, but they're more pretty for the presentations. And as you can see in the bottom, there is RISC-V version, and compiled only in the 2nd of May. Emacs has its own browser, so you can browse the RISC-V website from Emacs, which is quite amazing. But this is not very pretty, so I was looking at another browser, and this is what is working now. It's a full browser working with seeing the website of RISC-V. And even games, there are like 3D games that are running. This is a clone of Mario Kart with mascots of different free software projects. And, well, the RISC-V community can help by upstreaming the rest of the components and to test and report problems that we didn't find yet because the test suites don't catch everything. And this is the address that you can go, the central point where there are pointers to how to install and everything else. And what are the benefits for the RISC-V community? So just by having Debian or Fedora and other ports started, we found problems in the software stack, which when fixed, they are good for everybody, even not using these platforms. And packages that need support or fixes upstream the same. They will benefit from having this port. And even there are Debian people, for example, that knew about RISC-V through Debian, not through this 5. So it's bringing people to the community. And a large collection of software is useful for many reasons. Many people pay attention to this because of to these devices because of software. Like one of the success story of Raspberry Pi is for having a lot of software available. And it's easier to test extensions, to make benchmarks with real software and so on, instead of having synthetic benchmarks. And you can use it in your system and keep it. So you can get new software by apt-get install awesome package and get upgrades and so on. And the same with Fedora and other Linux ports. So you can make useful things with your port. And who did this? Well, from the Debian side, it's Carsten Merker, that you know from the mailing lists, and Aurélien Jarnot, who is working on GNU libc in Debian, and myself. We were the ones spending the most time over the last few months or years. And other people are starting to help, and many people spontaneously see the problems in their packages and start to fix that. So this is also they're doing. And Kurt Kevill from MIT, who is like trying to get around the idea of creating a RB 128 bits, and who was helping a lot with infrastructure. For example, the auto builders, most of them are running from there. And special thanks to Stephen Wallach from Micron, I hope that I get the name right, for sponsoring me to stay here, because the ticket is a bit expensive. So I would like to take the opportunity to ask to let contributors to free software to attend this workshop for free, because otherwise it's quite costly for us. We already have to reserve holidays and arrange hotels and so on. And Sci5, especially Paramount, asked for the Hi-Fi Unleashed that we got to help with porting. Bytemark, the hosting provider from the UK, sponsoring hardware for these cross compilations and so on. And Christian Svensson, because he started their OpenRISC or 1K port, and well, it got me hooked in a way, and so that's it. And finally, the Debian community, because it's an amazing project, and it's very easy to, well, not very easy, but it's feasible to create ports, and there are ports of many architectures. And there is good support for cross-compilation and so on. And to the RISC-V contributors and community for the creating another amazing project, which is very fun, and the courage to start from scratch, which is important sometimes. And that's it, the presentation.
What other performance monitoring tools are available now at the platform?
The performance, you mean? Well, I will be kind of happy to use it as my main desktop. Not maybe the desktop, because I don't have the card or anything, but they are like quite an usable computer. So they have 4 cores, and then you can get things compiled reasonably quickly. And well, if you depend on a lot of power for rendering, for video, I didn't test that. So maybe that's the problematic part, but I could use it as a normal server. Well, but that depends on the hardware anyway, so it's not exactly a problem of software.